Hello everyone, today we are going to present our engineering measurement project titled Design and Implementation of an Ultrasonic Radar System. This project was completed by me, Arya Panging, Shailin Ted, and Mingang Tu. The purpose of this project is to design a simple radar-like system using ultrasonic sensing technology, which can detect nearby objects and measure the distance using sound waves. So here's the agenda for today's presentation. First, we'll introduce the concept of radar and ultrasonic sensing and explain our motivation for choosing this project. Next, we'll discuss the objective of the project. After that, we'll explain the system design and the hardware components used in the implementation. Then we will describe the working method of the ultrasonic sensor and how the system measures distance. Finally, we will conclude the presentation with the expected outcomes and the application of the project. So radar systems are widely used in many fields for object detection, distance measurement, and motion tracking. A radar system works by transmitting signals and analyzing the reflected signals that return from the objects. These systems are commonly used in military application, air traffic control, navigation system, etc. Similarly, sonar systems work underwater using sound waves for mapping and object detection. Our project is inspired by this technology, but instead of radio waves, we'll be using ultrasonic waves to detect nearby objects. The main motivation of this project is to understand the basic principle of distance measurement using ultrasonic sensing technology. Another important motivation is its application in robotics and automation. Ultrasonic sensors are commonly used in autonomous robots, obstacle avoidance systems, and parking sensors. By developing this project, we gained lots of practical knowledge in electronics, embedded systems, sensors, and Arduino programming. So the main sensing components used in our system is the HCSR04 ultrasonic sensor. This sensor is used to measure the distance between the sensor and the objects. The working principle is fairly simple. So first, the ultrasonic sensor sends high-frequency sound waves towards an object. When the sound waves hit an object, they're reflected back to the sensor as an echo. So the sensor measures the time taken for the sound wave to travel to that object and return back. So the distance equals to speed multiplied time divided by 2. The division by 2 is necessary because the sound wave travels both to the object and back to the sensor. So it's a two-way. So this sensor at CSR04 has a range from approximately 2 centimeters to 400 centimeter, which makes it suitable for short-range object detection application. Now let's look at the hardware components used in the object. First component is the Arduino Uno. It acts as the main controller of the system. It reads the data from the ultrasonic sensor, processes the measurements, and sends the results to the computer through serial communication. It is also responsible for controlling the movement of the servo motor, which will rotate the HCSR04 sensor. Second component is the SG90 micro servo motor. The servo motor rotates from 0 degree to approximately 180 degree. In our system, the ultrasonic sensor is mounted on top of this, so the servo rotates step by step and the sensor scans different directions around the environment. This scanning movement creates like a radar-like effect, allowing the system to detect objects from multiple angles. So for the software components, we are using Arduino Uno. So we have to use Arduino IDE. So it will trigger the ultrasonic pulses, it will read the echo time and rotate the servo motor step by step. And send the formatted data angle and distance via serial communication to the laptop. And then MATLAB will receive this data from Arduino and it will convert the data into radar style visualization, as you can see here. And it will display the angle and the distance and the polar plotting to mimic the radar sensor, similar to this.
Hello, now I would like to present about the approach that we would like to conduct this experiment. So our approach is that we would like to have 50% like a physical experiment, and like another 50% of our project will takes place on MATLAB simulation. So this is the approach that we have come up with for the physical approach. We will be using Arduino and then we'll be using the real servo motor as well as the ultrasonic sensor to develop our system, and then we will like interface this system with Arduino to collect the measure results and create analysis. And here is the expected outcome of our system. So for the outcome, we would like to create a measurement detection system that can detect objects in real time with less uncertainty and with high accuracy. And in terms of analysis, we intend to do accuracy analysis and uncertainty analysis. And as you will see in the future slides, we have conducted some uncertainty analysis depending based on our project. So for the physical simulation, we have used Arduino and some breadboard to, and then like we will our servo motor and ultrasonic sensor. We developed this kind of system to detect the distance of the objects, and based on our physical experiments, the object can detect pretty accurately. And also another, and this part is another half of our project, which is like a MATLAB simulation. So we use MATLAB to collect the data and also to process the data and provide this kind of radar visualizations to clearly see where the object is and to clearly understand about the degree between 0 to 180 degree. So this is our project. And for the overall system flow, we have the distant input, and then our ultrasonic transducer will, so the way ultrasonic sensor will work is it will first provide like a ultrasonic waves to detect the object, and then it will and then like when the waves reach the object, they will also reflect back to the sensor, and the sensor will detect the waves, and like it will figure out the time, and it will also calculate the distance based on the algorithm, based on like a formula. And then it will provide like a signal to our Arduino, and our Arduino will like process this data to have like a like it will convert the voltage signals from the sensor to like actual data that we can see and utilize. And also we will conduct some signal conditioning and calibration methods to accurately to make our system as accurate as possible in relation to the real system. And then we will create like a radar visualization in our system, so that the user, and also the user can clearly see the distance and the object. So, and then my teammate will explain further details about like the real development workflow and the results from our experiment.
So in order to analyze the ultrasonic radar system, we create a MATLAB simulation. We create a prototype with MATLAB simulation, and then we analyze the environmental data with MATLAB software. So we create a plot with MATLAB script, and then we get the data from that. So this is we select the hardware. This is a basic main controller as a Arduino, and then for distance measurements, we use ultrasonic sensor HC as a 04, and then servo motor. So we use 180 degree servo motors to uh, check according to the angle. So in order to visualize the data, so we use MATLAB and then we use serial communication to transfer the data from microcontroller to our PC. Uh, in order to optimize the uh, sensor data, we use we in when we do the simulation, we got some small oscillations and like the data is not perfectly linear. So we try to make the sensor data to get uh, the best data. And then basically we use two types of techniques. First technique is averaging filter. This is basically like we measure 10 times and we would divide it with 10, so we got the average measurement data. And then second one is sensor calibration. So we got the corrected distance from by calibrating the measurement data. So the corrected distance is like we got a formula of 1.011 and multiply with the measurement data. We also subtract 7.5751. So this is the design optimization. So in order to save the data log, we use MATLAB code. We will save it with CSV file for future analysis. The data log parameters are like it's saved with ultrasonic, like it's saved with servo angle, and then measurement data in millimeter. So for uncertainty analysis, we basically use the RMSE formula. We find the difference between measure data and reference data, and then divide it with the number of uh, like data, and then like we put another square root. So we got the experimental result as like 0 plus or minus 2.45 millimeter. So thank you.